students, we are going to discuss about class 12 physics experiments. So first of all, we are discussing this is the question paper you are getting. So the first question we are discussing, determine resistance per centimeter of a given wire by plotting a graph for potential difference versus current. Actually it is Ohm's law. So how to write in exam? So for your thing I am writing it's Ohm's law. So in the exam first we have to write the aim. How to write the aim? It's very simple. Write the question. That means copy the question. Determine resistance. Just copy the question. That is your aim. Apparatus. In apparatus what you will write means come to the table, battery eliminator, voltmeter, ammeter, then rheostat. So there is a battery eliminator, voltmeter and rheostat, and this is the unknown resistance. So we can directly write from the table battery eliminator, voltmeter, ammeter and rheostat and the unknown resistance. So on the table we are writing. Now we are writing the theory. Theory we are writing Ohm's law statement. The current flowing through the conductor is directly proportional to the potential difference between the ends of that conductor. So we are writing that one statement. The potential difference between the ends of the conductor directly proportional to the current flowing through the conductor at constant temperature and pressure. That's a statement. V is directly proportional to I. So we can add V is equal to IR. So the resistance R is equal to V by I. So this is the equation we are using to find out the unknown resistance. Question is from the graph you find out the unknown resistance. So we are plotting a graph, x-axis and y-axis, and voltage in x-axis and current in y-axis. The nature of the graph, it's directly proportional, so it's a straight line. Drawing a slope by selecting 2 points. That point equivalent to A and this point is equivalent to B and this is C and this we are writing it as D. Slope of the graph, that is the resistance, so it will be AB by current it is DC. So now you want resistance per centimeter. So resistance per centimeter, this resistance divided by the length of that particular wire. So this is the way you are finding out the resistance per centimeter. So before finding out the observations, I am writing the circuit diagram, drawing the circuit diagram. It's a compulsory part. So it's a battery should be there and it's connected to a key and that is connected to voltmeter and that is connected to an ammeter and that's connected to a rheostat and that's connected across the voltmeter, that means parallel to the voltmeter there is unknown resistance X. Battery is positive is connected to positive and you see the negative is ammeter negative and this is positive. So this is the circuit diagram of Ohm's law. Now we need observations. So the heading observation. In that one, we are writing the least count of the ammeter. How to find out the least count of ammeter? See, you can see the ammeter, the first reading it is 0, and after the trend line it is 0.5. So the least count is 0.5 divided by 10. So it will be 0.05 ampere. First line it is 0, then next line it will be 0.05, then next line it will be 1, and next line it will be 1.5, 0.15, and it is least count of voltmeter. Here you can see the first line it is 0, and after 10 line it is 0.5, so 0.5 by 10, it's 0.05 volt. Each line it is a distance of 0.05 volt. Now we can draw the observation table. First column it is serial number, second column it is voltmeter reading and its unit is volt, and the third column it is ammeter reading and it is in the unit of ampere, and here the resistance VR is equal to V by I, and that is in ohm. Now the first reading, how we can take the reading? Before taking the reading, I have to connect this one. So we will arrange this one properly, so it's very easy to connect it. So just keep the battery eliminator, ammeter, voltmeter and rheostat on the side. So we are taking the reading in the ammeter and voltmeter, that is in front of you, and the parallel to that one battery eliminator, and in the side rheostat I kept. Now find out this unknown resistance. So that I am taking first, and this I am going to connect this wire parallel to the voltmeter. So this is connected parallel to the voltmeter. So that's a connected parallel to the voltmeter. Then I took the first connection and starting from the positive terminal, that positive terminal it is connected to the ammeter positive. And the next wire from the ammeter, so that I am taking from the negative of the ammeter to the positive of the voltmeter, and from the voltmeter I am connecting that one to the rheostat, to the down part. You can connect down or up. I am connecting to the down part. Then the next terminal from the upper part. Don't connect two from the down part. One it is down and one it is from the upper part. So from the upper part I am connecting to the negative terminal. So you can see the connection. It's a series connection from the positive terminal to the ammeter positive, and from ammeter to voltmeter, and from the voltmeter to rheostat, and from that to the battery eliminator negative. So you can see it's a series connection. And this is the ammeter and this is the voltmeter. Switch on the key so you can see the readings. The ammeter and voltmeter is deflecting, so the apparatus is working. So now you can change the ammeter and voltmeter reading by changing the rheostat. So we are taking the reading. You can see that the first reading you can see, you can count the line is from 0, 1, 2, 3, 4, 5, 6, 7. So it is on the 7th line. So it is 7 into 0.05. So the voltmeter reading it is 0.35 volt, or you can write directly. It is that big line it is 0.25, 0.3, 0.35, or you can write like this. So it's 0.35 volt, and the corresponding ammeter reading 0, 1, 2, 3, 4, 5. It is in the 6th line. So it is 6 into least count is 0.05, 0.05, so 6 into 0.05 it is 0.30 ampere. So voltmeter 0.35 and ammeter 0.30. Now you can calculate the resistance. 0.35 divided by 0.30, that much ohm. So your first set of reading is over. Now the same way you can go to the second set of reading by adjusting the rheostat. By adjusting the rheostat, the voltmeter reading will change, corresponding to the ammeter reading also will change. So you are getting the next volt you can take, corresponding ammeter reading also you can take. Like that, 3, 4, 5, 6 set of readings we are taking. And in 6 set of readings you will get 6 resistance. We are repeating 6 times with the different voltage and current, and after that we are taking the mean value of the resistance. So you got the mean value of the resistance. But in the question they ask from the graph, so we should draw with a graph. So I am drawing the x-axis and the y-axis. So in x-axis I am taking the voltage and y-axis I am taking the current, and you can take suitable scale. For example, here I am taking 0.2, 0.25, 0.3, 0.35, 0.4, etc. And in the current axis, that also I can take it as same or different scale, and mark the points there, and it should be a straight line. The nature of the graph, because its V is directly proportional to I, so it should be a straight line. From that we are drawing the slope of the graph. The slope of the graph we are drawing. After getting the straight line, we are drawing the slope of the graph, and we are marking just A, B and C, and the slope of the graph we can write it as AB by BC, and then the value of AB you can find out from the volt axis, the corresponding volt axis, and BC we will get from the current. So divide, so you will get the resistance in ohm. So you got the value of resistance by using the graph. Now you want the length of the wire. So length of the wire, that you take the wire. Before taking the wire, switch off the battery eliminator, and take the wire and find out the length of the wire by using a meter scale. This scale is not enough, so take a bigger scale and find out the length of the wire. And for example, if it is 35 centimeter, so the resistance per centimeter, you got the resistance, that divided by the length 35, so you got the resistance per centimeter. So that much ohm per centimeter. So now we can write the result. So the result is the resistance per centimeter of the given wire, that much ohm per centimeter. So this is our experiment, resistance per centimeter. Thank you.